Students of class 12th, today we will study we are studying the complexes. Now today we will explain the inner orbital complex क्या होता है और outer orbital complex क्या होता है. Inner orbital complex and outer orbital complex. Orbital complex. Now you study, students, inner orbital complex. पहले हम लेते हैं inner orbital complex में. If you study that these complexes are formed by the use of these are formed by the use of the complex formed by the use of inner d orbitals for hybridization. यानी इसमें D2sp3 hybridization होती है. जो central metal atom that use inner d orbital, that means n-1, and that is n-1 d orbital is used for hybridization. Since in inner orbital complexes, आप जानते हैं in inner orbital complex में जो है complexes, electrons of the metal atom जो होते हैं, they are forced to pair up. they are forced to pair up. As a result क्या होता है, this complex either is diamagnetic or it has lesser number of unpaired electrons. So it is called, we call it low spin complex. It is also called low spin complex. So inner orbital का दूसरा नाम हम इस बोलते हैं, they are low spin complexes, क्योंकि इनमें जो use of inner d orbital takes place in the hybridization. Use of inner d orbital takes place, and what happens due to this, जो electrons जो होते हैं, for the use of inner d orbital, the electrons of the central metal atom जो होते हैं d orbital के, वो pair up होते हैं. As a result उनमें या तो सभी paired होते हैं, that is they are diamagnetic, or there are lesser number of unpaired electrons, that these are called low spin complex. For example, I will take example of, let FeCN whole 6 tri-negative, फिर cyanide ion. You know, students, in case of this, iron is the central metal atom, and atomic number it is 26, and it is 3d6. इसकी outer electronic configuration है 3d6 and 4s2. Now I'll show 3d6. This is 3d6 4s2. Now 4s2 इसके बाद there is 4p also. These are 4p electrons here. Now iron, in this case it is, in this iron is +3 oxidation state. So iron third oxidation state, that means the 2 electrons from the s are lost and 1 this paired electron is lost. So the iron with third oxidation will state, in third oxidation state जो iron की होगी, इसमें electronic configuration जो iron की होगी, it will be 3d5. 1, 2, 3, 4 and 5, and 4s is empty, and here 4p is also empty. 4s and 4p. Now this is 3d orbital, it has 5 electrons. Now it has been found experimentally it has found that this complex has 1 unpaired electron. So to account for that, it is said that the electrons of the 3D, the 4s the outer orbital, n minus 1 is 3D, so 3D electrons pair up. Now during pairing up, so what happens, these 5 electrons pair up, so there remains only one unpaired electron. This one unpaired electrons, now two d orbitals are left vacant. Now here it is 4s and it is 4p. Now these are vacant orbitals. Now 6 pairs of electrons from 6 cyanide atoms. Now here one cyanide atom comes and occupy the space. One unpaired electron, one electron pair from cyanide, and here one electron pair from cyanide, one electron pair from cyanide, and here 6 cyanide atoms with 6 electron pairs, 6 cyanide group 6, one electron pair from one cyanide, another from another cyanide, and there are 6 cyanide groups. These overlap. These electrons overlap with, they form bond with, they occupy the vacant orbitals, and before occupying the vacant orbitals, these unpaired orbitals undergo the hybridization, and it goes D2sp3 hybridization takes place, and so the shape of this orbital is, it is octahedral shape. It is octahedral shape becomes octahedral, and this, it, since it has only it has one unpaired electron, so it is lesser paramagnetic, because it has only one unpaired electron. It is low spin complex. So you have read, in case of inner orbital complexes, these are low spin complexes. In these, use of inner d orbitals takes place for hybridization. D2sp hybridization takes place here, and in this case, the electrons are forced to pair up, and that's why they are either diamagnetic or they contain less number of electrons, so they are low spin complexes. The example is ferricyanide ion. Now another type of complex that's called outer orbital complex. Outer orbital complex, we also call them high spin complex. That is, these are the complexes formed by use of outer d electrons for hybridization. So outer electrons used for outer d electrons undergo hybridization, and in this case, inner electrons are not disturbed. Electrons are not disturbed. So this complex contain large number of unpaired, they contain a greater number of unpaired electrons. So they are paramagnetic. For example, I will take example of FeH2O whole 6 tripositive ion, this one complex. Again, iron 26 atomic number, so it will be configuration 3d5, 3d6, 4s2. It is 3d6, 4s2. So we will show diagrammatically, we will show it here. 3d6, 1, 1, 2, 3, 4, 5, 6, 3d6, 4s2, and there is 4p, and again there is 4d electrons. There are 4d electrons, 4d. Now in this case, here d orbital is not disturbed, and d orbitals are not disturbed. What happens? So 4s and we will first say what is the oxidation state. In iron, it is in +3 oxidation state. So in +3 oxidation state, this electron, as electrons will get lost, and one electron from the d orbital, it will also get lost. So here ये इलेक्ट्रॉन ये अब 3d5 रह जाएगी, 3d5, 4 electrons, these are 3d, now it is 3d5 oxidation in +3 oxidation state, in +3 oxidation state, the electronic configuration remains 3d5, 4s becomes vacant, 4p is also vacant, and I will show 4d here, it is 4p, I will show 4d here, 4d is also vacant, this is also vacant. So now this is 4s, 4p and 3. Now 4s, 1 4s, 3 4p, these, this one and 2 orbitals from 3d, they undergo the hybridization, go sp3 d2. So in case of this high signal complex formed by use of outer d orbitals, that is sp3 d2 hybridization takes place here. Now I will show 4s, these electrons here, 3d5 remains as such, they remain as such, 1 2 3 4 5, they are not disturbed, and 4s electron, it is 4s orbital is vacant, this 3d, 4p electron, it is also vacant, and 4d, 1 2 3 4, these are 5 orbitals. Now these orbitals, this 4s, this 4p, this 240, now they undergo hybridization, so it is sp3 d2, because only 2 orbitals from the d 4d. So now electron pair from one electron pair, one water aqua group, and another electron from this occupy these orbitals, and this one. So 6 water groups, 6 aqua groups, 1 2 3 4 5 6 occupy the position of 4 vacant orbitals, and this complex is highly paramagnetic, and the shape is octahedral. So you have read, in case of inner orbital complexes, inner d orbitals are used for hybridization, and the electrons of the metal atom are forced to pair up. So due to this, this compound may be diamagnetic, or it can be lesser paramagnetic, or it can contain less number of unpaired electrons, lesser paramagnetic. So example is ferricyanide ion. And in case of outer orbital complex, you have read that outer d orbitals take part in the hybridization and inner orbitals are not disturbed, so this compound is paramagnetic. This was the inner orbital complex and outer orbital complex.